All right, imagine for a second that you run a small artisanal soap factory. It's awesome. You make lavender soap, oatmeal soap, charcoal soap, maybe 10 different kinds in total. Your customers, they absolutely love the variety. But you've got a huge problem. You only have one set of machines. So how in the world do you decide what to make and when to make it without the whole thing turning into a complete logistical nightmare? Well, let's dive into that.
This, right here, is the central puzzle. I mean, making everything all at once would mean you'd need 10 separate production lines, and that's just incredibly expensive. But if you only make one kind of soap, you're going to lose all those customers who want variety. The answer, it turns out, lies in a manufacturing strategy that finds that perfect sweet spot in the middle, and it's called batch production.
So in this explainer, we are going to pull back the curtain on how factories manage this kind of complexity. We're going to start with the basics of what batch production even is. Then we'll walk through the entire planning process, from a yearly forecast all the way down to the daily grind on the factory floor. We'll even see how they keep it all on track and, of course, what the future holds for all of this.
Okay, so let's get our foundations right. What exactly is batch production?
Think of it this way. Instead of having a machine that only makes lavender soap 24/7, you use a general-purpose machine. You produce a big batch of lavender soap, then you stop, you clean out the machine, and then you produce a batch of oatmeal soap, and on and on. It's the perfect solution for when you can make stuff a whole lot faster than people actually buy.
Now let's contrast this with what we usually picture when we think of a factory. On one hand, you have mass production. Think of a soda plant. It's like a non-stop single-product fire hose. It's incredibly efficient, but you get zero variety. Batch production, on the other hand, is all about flexibility. It's a stop-and-start process that trades a little bit of that raw speed for the ability to offer that whole range of soaps our customers love.
Okay, so you've decided to use batch production. Smart move. But you can't just start mixing soap willy-nilly. The process actually begins with a very high-level, long-term view.
Before we even start to worry about lavender versus oatmeal, we first need what's called an aggregate plan. The planners, they get together and ask, how many total tons of soap do we need to make this quarter to hit our sales forecast? See, they're not looking at the individual products yet, just the overall production volume they need to satisfy demand in general. And this chart illustrates the core challenge perfectly. That curvy line, that's customer demand. It goes up, it goes down. Now, a factory has two basic ways to deal with this. One option, produce at a steady rate. But look, at the beginning, you make way more than you sell, which means massive storage costs. Later on, you can't keep up. The other option is to cheese that demand curve perfectly, but that means you're constantly hiring and firing people, which is also, you guessed it, incredibly expensive. The whole point of aggregate planning is to find the cheapest, most effective path right between those two extremes.
So, once that big picture strategy is set in stone, it gets broken down into what's called the master schedule. This is where the plan gets real. It is a detailed, week-by-week calendar that says something like, Week 1, we're going to make 5,000 bars of lavender soap and 3,000 bars of charcoal soap. Week 2 is for oatmeal, and this schedule, it basically becomes the Bible for the entire factory.
So the master schedule tells us what to make each week. That's great, but it doesn't answer the most crucial question of all. When we start a run of lavender soap, exactly how many bars should we produce before we stop and switch over to the next scent?
This classic sawtooth graph shows you the life cycle of every single batch. When the machine is humming along, your inventory rises. That's the upward slope. Then you stop production and you just start selling that inventory to customers. So the level gradually falls. That's the downward slope. When it takes too low, boom, you start a new production run and the whole cycle just repeats itself.
So how big should that peak be? Well, you've got to balance two forces that are basically at war with each other. On one side, you have setup costs. Every time you switch from lavender to oatmeal, you got to stop, clean everything, change the ingredients. That all costs time and money. So to keep those costs low, you'd want to make gigantic batches so you don't have to switch very often. But on the other side, you have holding costs. The more soap you make, the more warehouse space you need to store it all. And that costs money too. This, of course, favors making tiny little batches.
And this graph shows us exactly how to find that perfect balance. The falling curve, that's our setup costs. The more we make in one go, the cheaper each individual bar is to set up. But that rising line shows our holding costs. The more we make, the more we pay for storage. And when you add them together, you get this beautiful U-shaped total cost curve. Right there, at the very bottom of that U, that is the economic sweet spot. That is our optimum batch size, the magic number that gives us the lowest possible total cost.
All right, we now know we need to make 5,000 bars of lavender soap starting next Monday. Great. But
what do we actually need to make them? This brings us to the next, and believe me, incredibly detailed layer of planning.
This is where a system called Material Requirements Planning, or MRP, comes into play. You can think of MRP as the master brain of the factory's supply chain. Its entire job is to look at the master schedule and work backwards to create a perfect, time-synchronized shopping list and production schedule for every single nut, bolt, and bottle of lavender oil you could possibly need.
It does this through a really cool-sounding process called a parts explosion. Let's say our master schedule calls for 100 gift boxes. The MRP system explodes that order. Step 1, it sees it needs 100 finished boxes. Okay, step 2, it calculates that to make those, it's going to need 100 cardboard boxes and 300 bars of soap, maybe 1 lavender, 1 oatmeal, and 1 charcoal in each. Step 3, it then explodes those items into their raw materials, the oils, the scents, the labels for the soaps, and the flat cardboard for the boxes. And it does this for every single product on the master schedule.
As you can probably tell from this flowchart, this gets incredibly complex, which is why it's all handled by powerful software these days. The system takes the master schedule as its main input. It combines it with the product recipe and exactly what we already have in stock, and then it just crunches all that data. The output? Perfectly timed purchase orders for your suppliers and precise work orders for the factory floor. It's amazing.
So, we have the perfect plan. We know the optimal batch size, and we've ordered every single part we need. Now, it's time to actually do it. But, in the real world, things go wrong. How do we monitor a plan this complex in real time?
I mean, this is a serious challenge. With thousands of parts and dozens of different operations all happening at once, a simple checklist just isn't going to cut it. You need a way to see the health of the entire production process in a single glance.
And the solution is this really ingenious graphic tool called the line of balance. It was actually developed by the military to manage complex production, and it works like a visual dashboard, instantly flagging any part of the process that's starting to become a bottleneck.
Okay, I know this looks complex, but let's break it down. On the right, that's the progress chart. Each one of those vertical bars represents a step in our soap-making process. Cutting, stamping, wrapping, you name it. Now the magic here is that step line going across the bars. That is the line of balance. Think of it as the "you must be this tall to ride" line for our production schedule today. It shows the minimum number of units that should be finished at each step right now if we want to stay on track. We then just plot our actual progress. See those bars that don't reach the line? We can instantly see that operations 6, 7, and 10 are falling behind. They are the bottlenecks, and that is exactly where managers need to focus all their attention, right now.
So the systems we've talked about, MRP, line of balance, they were revolutionary. They really formed the bedrock of modern manufacturing. But, of course, the drive for efficiency never, ever stops. So let's take a quick peek at what comes next.
2 key developments have really pushed things even further. First, you've got Kanban, which was famously pioneered by Toyota. It totally flips the old system on its head. Instead of a central plan pushing work out to the floor, Kanban pulls it through. A worker only makes a new part when the next person in line signals they're ready for it, often with just a simple card. This little idea dramatically cuts down on wasted inventory. And then you have flexible manufacturing systems, or FMS. This is where automation really takes over, linking machines with robots and a central computer. It essentially creates a factory that acts like a single, adaptable organism, able to switch between making totally different products almost instantly.
From a high-level aggregate plan all the way down to finding that perfect batch size. From exploding a product into thousands of parts to visually tracking its progress on the factory floor, there is a hidden, complex, and honestly a fascinating science behind almost every single object you own. The efficiency of this whole system is what makes the variety and abundance of modern life possible. The question is, will you ever look at a simple bar of soap the same way again?